Welcome to our discussion on truth tables. If you're learning logic, then this is where the rubber meets the road. This is the important part. Being able to construct truth tables is our one and only objective because it is the one thing that will help you the most through getting through these truth and logic questions. Okay, oftentimes figuring out if statements are true or false, it can get a little convoluted and a little complicated. If you just are given simple, ordinary, single statements, it's very, very easy. But once you start adding in quantifiers and connectors and all these other things, it can get very difficult to kind of keep track of things. And that's where truth tables help. So a truth table is simply exactly what it sounds. Just draw yourself a simple little table, kind of looks like um, a table in Excel, and you put in the bits and pieces of the statement that you're trying to evaluate, and then you just go through all the scenarios and figure out when it's true and when it's false. So here's a simple example where we have a conjunction, a compound statement where we have A and B both represent statements. Think of, A is I like ice cream and B is I go to the movies. So I don't know why my table has A's and D's, but it was a typo. So just think of the D as a B. Okay. So the compound statement called a conjunction, that's your and, is true only when both statements are true. So it's only true when both A and D, in this case, right in the table, are both true. Now you might be asking yourself, where does the first set come from? Well, you always just start off with the basics of true, true, false, false, and then it goes true, true, right? And then true, false, false, true, false, false. So you can really go any pattern you want. Just make sure that you don't miss any combinations and you don't have any combinations written twice. So the easiest thing is to always come up with a simple pattern. You true, true, false, false, then you go true, false, true, false. If you have three things, so you had A, D, and let's say C, then you're going to have two choices for the first one, true or false, two choices for the second one, true or false, two choices for the third one, and 2 times 2 times 2 means you're now going to have 8 rows, right? So you had 4 rows here because you had 2 times 2. If you have 3 variables to deal with, then you get 8 rows. So the first one's going to be 4 trues, right? True, 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 4 falses. Then the next one's going to be sets of 2. True, true, false, false, true, true, false, false. And then the last one is going to go true, false, true, false, true, false, true. So you see how you start with 4 of each, then 2 of each, then 1 of each. And that pattern continues. So if you go out to 4 letters, A, B, C, and D, you now have 2 times 2 times 2 times 2, which is 16. Your table now has 16 rows. Big pain in the butt, but it's easily done. You'll now have the first letter will have 8 trues and then 8 falses, and then the next one will be 4, 4, 4, and 4, right? 4 trues, 4 falses, 4 trues, 4 falses, and then 2, 2, 2, 2, 2, 2, right? And then the last one will be true, false, true, false, true, false, all the way, all 16. If you just follow that pattern, you will always write out all the possible combinations without missing any and without writing any twice. Okay, and then it's just a matter of evaluating everything. So when A and D are both true, then the conjunction is true, and you can see for all other cases, it ends up being false. Because if just one piece of an and statement is false, then the whole thing is false. Because an and is a very restrictive statement. Think of it this way. Think back to when you were getting an allowance, if you ever did get an allowance from your parents. And in order to get your allowance, you had to do two things. Let's say you had to mow the lawn and take out the trash to get your allowance. Well, if you mowed the lawn and took out the trash, right? So if both of those things were true, you would get your allowance. But what if you mowed the lawn but didn't take out the trash? Are they still going to give you your allowance? No. If you took out the trash but didn't mow the lawn, you're also not going to get your allowance. And then the last case where they're both false, you didn't mow the lawn and you didn't take out the trash, they're surely not going to give you your allowance, right? So that's how I kind of remember that the and is very restrictive. You have to have both things being true in order for the whole thing to be true. The or is almost the opposite. It's called the disjunction. Who really cares? but it's a much more lenient statement. Go back to your getting your allowance example. If your parents then say, okay, instead of you having to do both to get your allowance, you just have to either take out the trash or mow the lawn and you get your allowance. So if you take out the trash and you mow the lawn, right? So this first case is you did both, true and true. You'd get paid, right? In this case, you took out the trash, but you didn't mow the lawn. You still get your allowance because they just said you had to do one or the other. Here, you didn't take out the trash, but you did mow the lawn. Well, you still get paid. And here, you were just lazy and said, screw it, I'm not going to take out the trash, I'm not going to mow the lawn, and you're not going to get an allowance, okay? So disjunctions are almost always true, right? They're true for every case except for when both pieces are false. Conjunctions are almost always false. They're false everywhere except for where both pieces are true, right? So they're kind of opposites of each other, but they aren't. Okay, the conditional is the if-then statement. If A, then B. And a conditional will always be true unless A is true and B is false. That one's a little trickier to remember, and it's tougher for students to wrap their heads around. But it basically comes down to the idea of it's kind of like you're making a deal that if you do A, then I will do B. And so if you come to my party, I will give you a present. That's my claim, right? I make the claim that if you come to my party, I will give you a present. Well, let's evaluate the four possibilities and figure out when that statement is true or false. Okay, so this first one is you came to my party and I gave you a present, so I kept my word. This is you came to my party and I didn't give you a present, I lied. That was false. This is you didn't come to my party, but I gave you a present anyways. That's still true. And then this one is, you didn't come to my party and I didn't give you a present, and guess what? That is still true. Even though I didn't give you the present that I said I would give you, I didn't have to because you didn't come to my party, right? So if A isn't true, then B can be anything it wants to. Do you notice how in both of these cases, right? A is false. It doesn't matter what B is, the overall statement is true. Because B is only held to being true when A is true. Otherwise, it can be whatever it wants, right? So the only time this statement fails to be true is when A happens and then B doesn't also happen. So this is the one and only one case where a conditional is false. Okay, so consider this one. If it rains, then we will stay home tonight. We'll let W be the statement, it rains, and then Z will be the statement, we will stay home tonight. So that gives us W implies Z. If we do the same thing that I just did with my statement and create a truth table, here's the same one, right? TTFF and then TFTF. And then the last column is going to be the conditional. And if we plug those in just like we did before, nothing changes, right? It's still going to be TFTT, right? It's still going to be true everywhere except for when it rained, but we didn't stay home, right? That would be the second row where W is true and Z is false. Z for all of you British people. Okay. How about constructing a truth table for a disjunction where we have A or not B? Well, that's no different than doing A or B. It really isn't. The only difference is you now have to figure out what not B is. So when we do a normal A or B, and I'll do it over here on the left, right? We do A or B. We go true, 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 false. This is the only time that's false because both pieces are false, right? But now we're going to do A or not B. So we have to deal with what not B is. Well, not B is just the opposite of B. So this becomes a false, true, false, true. And now when we're doing this piece, we're looking at this and this. So we go, okay, true and false, that's good. True and true, that's fine. false and false, that's where we get a false, and then false and true, that's okay. And you can see that this is our only false because that's where we have the two falses because we're using A and not B. Now, the one piece of advice I'm going to give you guys is when you're doing this for real, don't make your table this way. And what I mean is you don't want a gap between the two things that you're trying to look at together, right? We're doing a disjunction with A and not B. You don't want to be jumping over this column and looking at these two to figure out your answer because it's too easy for your eye to look at this one instead of this one, and in this case it wouldn't matter, but this one instead of this one, and get the wrong answer. So what I would suggest is make your table like this, that's fine, put in your not B, and then go ahead and rewrite A right here. It takes 3 seconds, right? 1, 2, 3, we're done. And now when we're doing our final answer, we're just looking right here. And we're going, okay, false and true, that's a true. True and true, that's a true. False and false, that's a false. True and false, that's a true. And we don't run into the possibility of making the mistake of looking at this column instead of that column. So it's these simple little things that's going to help save you guys from getting answers wrong on a test. Always take the time to draw in an extra column to put the pieces that you're really dealing with right next to each other. And it really becomes helpful when you get statements that are more convoluted, that you have a compound and a disjunction and a negation, all these things put together. Okay, so here we're just working through what we already did. To summarize, we have the symbols that we've already seen, the squiggle for negation, right? The little caret, the V, the arrow. Do you want to memorize when these things are true and false? No, darn it, don't. It's too much to memorize. Just work them out, do a table each time. All right, let's try another one. How about if you're not making mistakes, then you're not doing anything. Now, this statement may seem easy to write down at first glance, but when we list out the simple statements without using the negations, you can see that it gets a little tricky. And this is key, guys. Statements always need to default to standard ones. If you're not making mistakes, then the original statement has to be you are making mistakes. That would be your P, and this you're not making mistakes is actually the negation of P. I know you're thinking that it doesn't matter, that it's all the same, but it really isn't. You're going to run into trouble and you're going to run into problems later on with more complicated questions if you get in the habit of letting you are not making mistakes just be A. You can't do that. You want to let you are making mistakes be A, and then the negation of A, or what I call squiggle A, that becomes you are not making mistakes. Trust me, guys, you want to get in the habit of doing this, otherwise you will make mistakes in the future. Okay, so we set up this table with our normal A and B, with our trues and falses. Then we make the negations of the two things. So all we're doing is making the negation of A and making the negation of B. Very simple. And then now we go ahead and do the conditional based on these two things. So a false to a false is true. A false to a true is also true. A true to a false is where we finally get a false, and then a true to a true is a true. Because remember, when we're doing a conditional, the only thing that matters is if the first part is true and the second part is false, then you didn't hold up your part of the bargain, and that's where it becomes false. Everything else is true. How about trying this one? Construct the truth table for the conditional statement in 3 and let A and B be the following. You're not making mistakes and you're not doing anything. And see if it changes things. Well, here's what you get. A is the not, right? And B is the not. And we get the same thing as far as 3 truths and 1 false, but the truth tables are not the same. They're in a different order, right? So we've got true, false, true, true, and look at what we had this way. True, true, false, true. See, so as I told you guys, you need to let A and B, or whatever letters you want to use, represent the standard statements. and then you have to negate them if the statements involve, negative words like not this or anything that's the opposite. Okay, a tautology is a statement that is true in all possible circumstances. So, was this statement a tautology? No, because it had this one false. Was this statement a tautology? No, it also had one false. And in fact, so far we haven't seen any tautologies in any of our examples. But there are examples of tautologies, and we will see some. How about constructing the truth table for the following compound statement? Next year, Emery can take physics, or he cannot take physics. So we're going to let C represent Emery can take physics next year. Then the statement C is the first part of the compound statement. And Emery cannot take physics is just the opposite of that, right? That's the negation of that. So that's just not C. So now we're going to have C or not C. Here's C, it's either true or false. Here's not C, which is either false or true. And when we do the or, a true and a false is still true, and a false and a true is still true. And so therefore, the statement next year, Emery can take physics or he cannot take physics is a tautology since all of the truth tables are true. And it makes sense because if you think about it, that statement is always true because either one or the other thing happens, so that is a true statement. It's kind of like saying, if you flip a coin, you'll either get heads or you won't get heads, i.e. tails, and that is always a true statement, unless you think you can flip a coin and land it on its edge. Okay, how about this? The following response opinion on immigrant fishermen being jailed in Davidson County, printed in a paper, is if they come here illegally, then commit more offenses while they are here, no matter how small, they will eventually commit greater offenses. So now we want to construct a truth table for the statement given in the newspaper. Well, you have to break it up into its little pieces and figure out where all the statements are, give them some letters. You see that it has an if-then in it, so we know it's going to be a conditional. So if blah, 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 and blah, 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 then blah, 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 right? We have to kind of key into the important pieces. We have an if-then in there, and we have an and in there. So we know we're going to have a conjunction and an if-then. So we're going to let P be the first statement. They come here illegally. We're going to let Q be the next statement. They commit more offenses while they are here, no matter how small. And then we're going to let R be the final statement. They will eventually commit greater offenses. Does it matter that we let it be P, Q, and R instead of A, B, and C? No, doesn't matter at all. Does it matter that we do them in order? Not really, but it's just the best practice that as you go in order, the first statement becomes the first letter, and so on and so forth. So that means we can take this entire English statement and write it as they come here illegally, that's P, and commit 4 offenses, blah, 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 that's Q. So there's P and Q. And this says, if this happens, then this happens. So if all that happens, then this thing happens. So there's my if-then statement. We can build our truth table, and like I said before, we get 2 options for each letter, and because we now have 3 letters, we're going to have 2 times 2 times 2, or 8 total rows. And here's that example of 4, 2, and 1, right? 4 T's, 4 F's, then 2 T's, 2 F's, 2 T's, 2 F's, and then 1, 1, 1, 1, 1. That's how you set them up. And then it's just a matter of evaluating them, figuring out each piece as to whether it's true or false. Now, this is kind of tricky. It's not tricky, but you could make mistakes by doing P and Q here instead of doing right next to it. I technically would have written my table the other way, and I would have put P and Q right next to P and Q to make it easier to not make a mistake, right? Because I know an and is only true when both things are true. So anytime I see a false, I know everything is going to be false, and I only get these 2 truths. And now I can evaluate P and Q going to R because now I've got them right next to each other, and I have this implies this, right? This is like a new letter. This is like S implies R, where this equals S. So I'm saying true implies true. True implies false. Okay, that's that one case, right? Remember where if the first thing is true and the second thing is false, we're in trouble. But if the first thing is false, it doesn't matter what the second one is. They're all true, because if the first thing doesn't hold up its end of the bargain, then the second thing doesn't have to do anything. It can do whatever it wants to do, and the statement is still true. That's the way I would tackle it, guys. Here's the way the book does it. And you can see that once they do the work, they get the exact same thing we did, but all they did was they rewrote the R statement here to do this, to basically point out the same thing that I point out, that it's much safer to kind of put everything next to each other and keep it in order, so you know that this is implying this instead of kind of going backwards when you're looking at this row to that row. Okay, so it's really going to save you guys headache and save you mistakes if you're writing in extra columns than what would normally be thought. And that's really my biggest kind of advice. Now, based on the truth table, we can see that this is not a tautology, and because it's not a tautology, meaning it's not all true, then we would say that the statement is not accurate. Okay, the quantifiers never and always in these sentences should make you hesitant to draw conclusions when they are used as part of a logical argument. Just keep that in mind, that never and always are absolutes, and it's very hard to have an absolute be true. The only time an absolute is true is when you have a tautology. So, when in doubt, when you see nevers and always, your thought should be it's probably not going to be true, because tautologies are pretty rare. All right, hope this helps.